Today we're going to learn how to identify a function. We're going to talk about what a function is and how to know when we have a set of values that is indeed a function. And then we're going to talk about what the domain and the range of that functions are. And we're going to learn how to identify them. So let's look at our first opening exercise here. We have a bunch of pictures of animals. And we have to match each picture to the correct word by drawing an arrow from the word to the picture. Now, what in the world is this and what does it have to do with math? Actually, everything. It's going to help us talk about correspondence and the idea of correspondence in functions. So let's look at the first animal. If I ask all of you in class what this animal is, I sure hope all of you would say that this is a polar bear. Because, and I'm going to actually draw in here what this would look like if this were a function. Let's say that X is my animal and that f of X is the name of the animal. I'm gonna draw the best looking bear in the world right here. There we go. Watch out, Picasso, here I come. All right, and this is going to be a polar bear. And we're basically doing the same thing that we are doing by drawing arrows. But a table really just helps me visualize what it is that we're doing. And when I show you this animal, you're going to say, oh, that's a camel. The next animal is going to be an elephant. Here we go. And then the last one, of course, is going to be a zebra. And it's different from a horse because it has stripes of black and white. Or is it white on black? Okay, so this is what my table looks like. The main idea here is for us to draw a relationship and a connection between what we just did and what a function is supposed to do. Now, a function, you wouldn't have to deal with images necessarily. You could. But you won't, more than likely, and you will deal with usually like some sort of explicit formula or rule, and then an x value that you have to plug in, and then out comes the function of x or the y value, right? A function is basically a correspondence between two sets, x and y. In this case, in particular, we have basically the animal that corresponds to the word polar bear. Now, if I showed you this animal and you wrote camel, you'd be all weirded out because this cannot be both a polar bear and a camel. It can only be one thing. That is what we mean by correspondence. This shape can only correspond to a camel. When I show you this shape, you will say elephant, and it cannot be a zebra and an elephant because one shape stands for one item. And so that's what we mean. And that's essentially how functions also work. When we use the notation x arrow y, that just basically means, hey, this is x, and my arrow, I'm drawing it to the y value and only corresponds to that one y value. The value of x, there can only be one of them that corresponds to something else in y. So I would not be able to show you another beautifully drawn elephant and it'd be a zebra. That would not happen. You cannot have two elephants. You have to choose one elephant. So that's basically how functions work. The domain in here for this opening exercise would be all my x values. So this is basically the domain, all these shapes. And I would normally write it, in some sort of notation that begins with open brackets. And I'm not gonna try to draw these animals again because, yeah. Anyway, that would be my domain, and my range in this case would actually be the word bank. Polar bear, camel, and you should be able to draw correspondence with the terms in the same order as they are with y. All right, so let's move on. Let's go ahead and jump directly and try to apply that concept of the animals and one-on-one correspondence with an actual function. In this case, we have two functions. And actually, we don't have what the actual formula is, but we just have their domains and their range. So let me go ahead and put these in a table. Going to have two tables. One I'm going to use for f of x. We have x and f of x. And then this other one I'm going to use for g of x. And then I'm going to plug in these values. So in this first set of ordered pair, I see that my x value here is a 1, a 2, a 3, and a 4, and then the y value is 7, 5, 6, and 7. And then for my g, is f a function? And is g a function? Now remember, from our lesson last that a shape correspondent to one thing, right? That is what we say one-to-one correspondence. And we talked about x being the independent variable and y being the dependent variable. So basically what we mean is this value here is going to depend on whatever x is. Because it's a dependent, it is possible that it could have more than one value. So let's look at f of x. We have 1 corresponds to the 7, 2 to the 5, 3 to the 6, and 4 to the 7. And so a couple of things here. We can have the dependent variable y repeat itself. And the reason we can do that and we can have that situation and it still be a function is because it corresponds to a different independent variable. In this case, it corresponds to a 4, and in this case, it corresponds to a 1. And remember, because this is dependent, it's okay for it to repeat itself. So for example, if you think about everybody in the class, if I can just illustrate another example. We are all individual people. We have our own individual name. We have our own individual social security number, student number. We are all very different individual people, right? And so if I were to say, you have black hair, brown hair, or blonde, or other, right? So this person can have brown hair. This person can have no hair. This person can have blonde hair. So this would be the independent variable, and the type of hair or color of hair would be your dependent variable, because it depends on who has the hair. We're going to look at that head, and then whatever, if it's brown, none, blonde, then it's going to depend, right? But it is possible for multiple people in the class to have brown hair or blonde hair or no hair. It is possible for that situation to happen because y is dependent on the individual independent variable. And that's the main idea of functions, right? We have to recognize that in functions, what matters is the x value. And as long as those do not repeat themselves, just because two people have brown hair, it does not mean that they're the same two people, right? When we look at this function right here, even though the value of 7 repeats for the dependent variable, they correspond to a different independent variable, to a different x. And so it's okay, and that still makes it a function. It is possible that it's still a function, okay? Now, let's go ahead and look at this next one. G of x, we have 1 that corresponds to 5, 2 that corresponds to 6, 1 that corresponds to 8, and so on and so forth. So first thing that you notice is like, oh, the dependent variable does not repeat. That's cool. Now, in this case, though, I have the independent variable, 1, that corresponds to two different variables, 5 and 8. I can't, and I'm going to bring it back to the example of the hair here. I can't say that my name is Claudia Romano and I have no hair, but I also have brown hair. That's not possible. I either have no hair or have brown hair. This cannot happen. My independent variable cannot correspond to two different y values. So this tells me this is not a function. So basically, to answer these questions, is f a function? Yes. Function, what is the domain? So when they're asking for the domain, they're asking for the x values. And what is the range? They're asking for the range for the y values. So in this case, the domain would be 1, 2, 3, 4, and then the range would be 7, 5, 6, 7. And we of course write it in the same order. The next question is g a function? The answer, of course, to that is no, so we don't have to worry about domain and range. Then they ask you, what is f of 2? What is f of 2? So we're going to grab the function f in here. What is f of 2? We look at the table. F of 2 corresponds to 5. And so they say if f of x equals 7, so what might x be? So in this case, they're asking if f of x equals 7, then x could be either 1 or x could also be 4. A student, a unique ID number, is this an example of a function? And the answer to that Of course, if you have a student and have a unique ID that corresponds with your student, yes, that would be a function, because we can't have a student with two different IDs. That's not going to happen. What if we have suppose f of Hilda? What does that mean? It means that 350123 is Hilda's ID, and only Hilda's ID. Now let's look at number 2. Let G assign each student at your school to a grade level. Is this an example of a function? What do you think? Let's see. We have a student, and they belong to a grade level. And we have a different student. This one's a little bit taller. And they belong to the same grade level. Is that a function? The answer, of course, is yes. Why? Well, because as long as the same student is not assigned to two different grade levels, you can't be in 6th and 7th grade at the same time, can you? No, you cannot, despite what you want to think. You cannot be in 8th and 9th grade at the same time. So they may belong to the same grade level, but they're two different students. And so as long as they're two different students, remember, my independent variable must remain independent. My grade level can only be 5, 6, 7, 8 if I'm in middle school. So you don't have to actually, we're not going to actually name each one of you in the class, but that's kind of how that would look like. For the problem set, you're going to be given a situation as well, and you're going to have to figure out if they are a function or not. You can just write yes or no. And then they're going to also ask you to think about what the domain and the range for the function would be. And they give you an example of how you write it there. So make sure you know how to do all those things before you get into class tomorrow.